What is the aurora borealis, and what causes it? An aurora, A-U-R-O-R-A, is a multicolored glow in the night sky. A typical aurora is a shimmering curtain of blue-green light with patches of pink and red. These ribbons of color may be more than 100 miles wide and can stretch for 1,000 miles. Dancing like flames in the dark sky, an aurora is a planet's own light show. Auroras appear on Earth, but are triggered by events on the faraway sun. Here's how it works. The sun is a glowing ball of gas made mostly of hydrogen and helium atoms. All atoms have particles called protons at their centers. These are orbited by other particles called electrons. Protons have a positive electrical charge, while electrons are negatively charged. The halo of superhot gas surrounding the sun, called the corona, C-O-R-O-N-A, is constantly expanding into space, sending bits and pieces of atoms off in every direction. This is what we call the solar wind, made mostly of protons and electrons zipping along at up to 600 miles a second. Meanwhile, solar flares shoot violently out of the sun now and then, releasing a gust of new particles into the, quote, wind, end quote. When the solar particles near Earth, they start to feel the effects of our planet's strong magnetic field. The Earth is like a giant magnet, with lines of magnetic force curving out into space and converging near the north and south poles. Its magnetism is believed to be caused by electric currents created by the rotation of the Earth's iron core. To see how magnetic fields work, hide a bar magnet under a piece of paper. Now sprinkle iron filings or tiny iron nails onto the paper. They should line up in curving lines around the magnet, showing the shape of the magnet's force field. The Earth's magnetic force lines attract passing charged particles from the sun, pulling them in. Pulled-in particles travel in beams along the lines, which bend back to the Earth at the magnetic poles, which are near, but not at, the north and south poles. As the particles travel along the invisible lines, they are unceremoniously dumped into Earth's atmosphere in the far north and south. Now the fun begins. Our atmosphere is made mostly of nitrogen and oxygen. When the electrons and protons stream in from the sun, they collide with nitrogen and oxygen atoms high up in the air. Some of these atoms lose some of their own electrons, and others get, quote, excited, end quote, gaining energy. When these atoms return to normal after their rush in with the solar protons and electrons, they give off photons of light. Nitrogen that has lost electrons emits violet and blue light, and excited nitrogen glows a deep red. Excited oxygen gives off green and red light. So the charged particles from the sun cause the air to shimmer in many colors. This is the aurora. The glow near the North Pole is called the aurora borealis. It's also known as the northern lights. The glow near the South Pole is named aurora australis, also called, you guessed it, the southern lights. An aurora appears almost nightly at the North Pole and 20 to 200 times a year in northern Scandinavia and North America. There are even 5 to 10 auroras each year near latitudes as far south as those of London, Paris, and Seattle, and the ghostly lights have even been seen in Mexico. Aurora borealis, suggested improvements. 1. Add music. All good light shows are orchestrated. 2. Refreshments. What's a show without something to eat? 3. Timing. Regularly scheduled solar flares, preferably on weekends.